Now, the easiest thing to see what happens when we translate a parabola is actually just to do one and note what happens. So we've seen how to do this by making our replacements. We change x into x plus or minus something to move it to the left or right. So if we're translating y equals x squared 2 units to the right, that's going towards the positive numbers, and we've learnt that that means we need to subtract 2 from the x. So have a look at what the x is doing here. The x is being squared. So that means that we need to just replace the x with x minus 2, but we still need to square that x minus 2. And then to move our curve 1 unit up, we've got two choices. We can actually replace y with y minus 1, remembering that to go up towards the positive numbers, you do the opposite, which is to subtract 1. But we've got another method, which is that we can actually just, if we're working with a function, which we are, we can just tack a plus 1 onto the end. And that made sense when we looked at making a table of values to figure out y for any given value of x, and then at the last minute saying, oh, let's add 1 to that. It's almost like an afterthought to tack it on at the end, and that does move it in the way that's sort of logical, or as you'd expect. Now, what we've got here, you should recognise, because we've already looked at what we call vertex form of a parabola, and we said that if it's in this form, which of course now it is, then we can just read straight off the graph that the vertex, read straight off the equation that the vertex will be hk. So here, the vertex will be 2, 1, and that makes complete sense because our original parabola had its vertex at 0, 0. So if we took that vertex and moved it across 2 and up 1, of course it is now going to be sitting at the point 2, 1. That makes complete sense, and it's going to have the exact same shape but moved across and then up. So vertex form, which we've already learnt, should now make a lot more sense. We looked at one proof for why the vertex had to be hk, and that was to do with this part here being positive, which meant that the minimum value of y would actually be k, and subbing y equals k in, we got h. But this is an even better proof because it marries in with our understanding of translations and how we can move our basic parabola across one way or the other and up or down in either direction, and we will have moved the vertex 0, 0 to that new point, hk. So we should now be able to look at any equation for a parabola when it's in this vertex form and describe it as a translation of the basic parabola y equals x squared. In this first one, replacing x with x plus 5 moves it 5 units to the left. So this one has moved 5 units left, and then the plus 2 has made it go 2 units up. And that makes sense because the vertex of this would be negative 5, 2. Here we've changed x into x minus 3, and that moves it 3 units to the right, and the minus 1 has dropped it down 1. And that makes sense because the vertex here would be 3, which is 3 across from 0 obviously, and negative 1. Having a number out the front here doesn't make any difference to where the vertex is. This number here is like the a value, it's the coefficient of x squared, and that just stretches the parabola one way or the other. So here what we've actually done to the x is replaced it with x plus 8, and that moves the basic graph 8 units which way? To the left, and the negative 4 shifts it 4 units down. So then it makes sense that the vertex of this one is negative 8, negative 4.